Hello everyone, this is Professor Lee again. Today we are going to talk about descriptive statistics, chapter 2.2. Right? I'm going to talk about histogram, frequency polygon, and time series graph. Now this would be probably one of the first substantial chapter that we really need to pay attention, right? Meaning, like, a lot of exam is going to come from this chapter, right? And not just to get a higher grade in exam, but this is one of the key chapter that you really want to understand in order to understand the whole course and in order to learn statistics, right? So let's give extra care for this chapter, right? So first thing that we are going to check is what's called the histogram. Now, so we are going to learn to build this histogram. Basically, histogram is like a graph. And let me give you a quick example of histogram. Histogram looks like this. I mean, you've seen this type of graph, looks like this. So let's go one by one. So consists of adjoining boxes. So you see these boxes, they are all connected together. They're not a separate bar. If it's a separate box, then we have separate name for that type of graph. We call that bar graph. Histograms are not like that. Histograms, they are all connected together like that, right? That's what they mean in this first sentence. I mean, think about it. This came in the first sentence, meaning this is one of the main characteristic of histogram. So it has both horizontal axis and the vertical axis. So, the horizontal axis is called that H, and the vertical axis is called that V. Usual X and Y axis, right? The horizontal axis is labeled with what the data represents. So this represents data, right? What the data represent. For instance, distance from your home to school. So this axis, the usual x-axis or the horizontal axis, that refers to the data. What about the vertical axis then? Vertical axis labeled either frequency or relative frequency. So this one is going to be either frequency or relative frequency. That's going to be the vertical axis, right? Now, it could be in a percent form, right? The percent, frequency, or probability sometimes. But something to do with the frequency or the percent is going to be the y-axis, the vertical axis. And what represents the data is going to be the horizontal axis, the x-axis, right? Now, the graph will have the same shape with either label, right? So graph will have the same shape with the either label, right? And the histogram, just like the stem and leaf plot, will give you the shape of the data. It shapes like this, for example, and the center of the data and the spread of the data. I mean, if you look at the histogram, then you will know whether this data set is highly concentrated or very spread out, and is concentrated around this area right here, or is it this other area? You can see right away just by looking at the histogram. Now, the rule of thumb to use histogram data consists of 100 data point or more. So if when you have 100 data point or more than 100 data point, then you use histogram, you build a histogram to present the data. All right. Now, that's a usual case, but for our learning purpose, we may deal with less than 100 data point. Let's say, 20 to 25 or 30 data point, then we'll try to build a histogram. But usually, they use more than 100 data point. So this is like a quick overview of histogram, right? We didn't actually learn how to build this one yet. So histogram, you need to figure out how many bar that you are going to use. This how many bar, sometimes this is called bar, but more often it's called classes. How many classes are you going to use? For example, let me give you an example. Let's say you build a histogram and let's say it looks like this. Then how many class or classes did you use? Well, we used 1, 2, 3, 4, 5 classes, right? We used the 5 classes here. So class, sometimes they call interval, sometimes they should say bar, but it's usually class is the proper name or popular name. So how many classes are recommended? Because if you are doing this project, if you are building this histogram, it is you who have to decide how many classes that you are going to use. Well, recommended number anywhere between 5 to 15 bar, right? So you don't want to have like 200 bar here built up because that's too detailed. And you don't want to have like, for example, 2 bar like that because it's too general, right? So not recommended. Anywhere between 5 classes to 15 classes are recommended, right? Okay, so choose the starting point of the first interval to be less than the smallest data value, right? So in a way, you are going to arrange this bar from small value to the large value, right? And of course, right? So let's say you have this example. Let's say you have this frequency distribution table. Now, let's say we have to complete this table. Now, anything that looks like this table form is called what? It's a frequency distribution table. Sometimes they say frequency table. Sometimes they say frequency distribution table, right? Doesn't really matter. Now, look at this class boundary, right? So you have 1, 2, 3, 4, 5, 6, 7 class boundary right here. And later on, we are going to learn how to actually set up this class boundary from the raw data. But for now, they already did all this work for us. So we're going to work with this. Now let's think about this first line. What does that really mean? Let me give you a little bit of time. What does that really, first line, this boundary and frequency really means? Right? Okay, I don't really like this Y right there. So let me make it a little bit bigger so that we can have that. Oops, okay. Y up there, okay. So, talking about this first line, what does that really mean? We have frequency of 2 between this number and this number. So we don't know the actual data. But what we know is this. We have two data points, anywhere between 33.5 to 38.5. That's what we know. Oh, now that we moved the y, now this t in midpoint got moved again. So let me push this guy. That's better. Okay. So we know that there's a two data point between these two values. Now what about, for example, this line right there? We don't know exact the data point, but we know there are 14 data points between this number, 53.5 and 58.5. We know there are 14 data points. Now, midpoint. Now, what do you think this is? Midpoint of what? Well, take a wild guess. I mean, you can certainly figure out this midpoint, right? Midpoint of what? Midpoint of this class boundary, of course. So, how do you build this midpoint? Now, the way that you do this is that you add this lower class boundary plus the upper class boundary, and you divide that by 2. So let's say you add 33.5 plus 38.5, then what do you get? You get 72, just like that. And you divide that by 2, then you get 36. So this midpoint is going to be 36, just like that. Now, you can pause your video at this point and try to build all this midpoint, right? Why don't you do it right now? Why don't you pause this video and try to build all this midpoint, right? You know what? Your exam, including your midterm and the final, is not going to be that different from this. It's just going to be like this, right? Questions that posed in this way, then ask you to build this. Okay. So this, let's just do one more. Let's say this next one right here, this point. What do? You add 38.5 plus 43.5. You can see where do we get these two numbers, right? We get this number from this and this, and divide that by 2, right? So, you know, 38.5 plus 43.5 is 82, and divide by 2, 41. So this is going to be 82 divided by 41, and just like that, right? Just like that. Okay, so I mean, not 2. This is 2. The result is going to be 41. So it's going to be 41 here. Okay. And if I just cheat a little bit, this is going to be 46, 51, 56, 61, and 66. Just like that, right? Okay. Now, and there's a total that you also have to calculate. So if you add all this number together, it's going to be 50 right there. And midpoint, technically you can add. If you add it, it's going to be 357. But in many cases, you don't really have to add this midpoint. So we'll just leave it blank for now. Now, what do you think this is saying? F times, this is multiplication, so this is F times the X, which is the midpoint. So basically, this one is saying, why don't you multiply 2 times 36, right? Which is what? 72, right? And this one right here, saying what? This one is saying, why don't you multiply f, which is 4 times 41. So I guess this is 164, right? Okay, and this is same thing. This is 7 times 46, and this is going to be 322, and so forth. Well, you get the idea. So you do all that. The next one is going to be, this is the actual answer. So when you do, we did all this. This was given. We got this by adding all this. We got all this midpoint, right? We got all this midpoint. This one is optional. You don't have to calculate this. Now this one that you got, multiply 2 times 36, you got this. 4 times 44, then you got this. 7 times 46, then you got this. And so forth, right? You get the idea. Because it says right there, f times x. So once you get all this, and you add all this, you add all this number, and you got this. So this number came from 72 plus 164 plus 322 plus 408 plus 784 plus 732 plus 198. Then that's going to 2,680, right? This number right there. Now, and why do we need this number? Using this number, we are going to figure out the frequency, the relative frequency, right? The relative. Well, using this number later on, that we are going to figure out not relative frequency, but something else. But for now, now we also need to figure out the relative frequency. Now, how do we figure out the relative frequency? Relative frequency is the frequency of each class divide the total of frequency. So this number right here, for example, came from what? 2 divided by the total, 50. Right? If you type up 2 divided by 50 in your calculator, this is what you get. Where do they get this number? Well, same thing. 4 divide 50. What about this one? Same thing. 7 divide 50. What about this one? 8 divide 50. Right? What about this one? 14 divide 50. Same thing. 12 divide 50. And this one, 3 divide 50. And all this, you can leave it as decimal like this, or you can change that to percent. So for example, this one would be 4%, 8%, 14%, 16%, 28%, 24%, 6%. Now, if you add all this percent, you are going to get 100%. If you add all this decimal number, you are going to get 1. Now, let me make just one point. Sometimes you don't really get exact 100. You get a little bit bigger number or a little bit small number. Same thing for this. Why? Because sometimes then you have to deal with the rounding off error, right? In this case, this is nice clean number that you don't really have any lingering decimal hanging around that you don't have to cut somewhere and round it off. But sometimes you do have that problems. If you do have that problems, then you may end up with something a little bit small, something a little bit big, and that's totally fine, right? So we completed the table just like this. Okay, now look at this one here. Construct frequency histogram. Construct frequency histogram. Now, given that, you know what, let me clear all this calculation by getting out. Discard and going back again. So, given that this is our table, now we are going to try to build frequency histogram. Frequency histogram uses which column? Well, frequency histogram use this class boundary as x-axis and frequency as y-axis, right? So let me give you, and start from what? 33.5, right? So look at this number right there. Where do you think they got this number? I mean, it even says it here, class boundary. So 33.5 goes up to 38.5. This is first class, and they put it like that. And what was the frequency of the first class? I mean, it goes up to 2, right? Let's check, right? It goes up to 2. Now, next class boundary is 38.5 to 34.5, and it goes up to 4. So 38.5 to 43.5. I mean, you don't have to write it in this way. You can just say this point is 33.5 and this point is 38.5 and this point is 43.5 and 48.5, 58.5, and this is 63.5, and the last one is 68.5, right? You can just write it like that. And the first bar goes up to 2 frequency. The second bar, second class, goes up to 4. And what was the next one? Goes up to 7, I guess. Let's double check. Yes, it goes up to 7. Now 8, 14, 12, and 3. So, yep, 14, 12, and going back to 3, just like that. So, I mean, I used Excel to draw this, so they don't have this axis, but if you just graph it by hand or something, then you will have this X and Y axis just like that. Let's pretend that this is a straight line, and we have this bar shaped like this, right? And this is what we call frequency histogram, right? Now, the last part is, it says construct now relative frequency histogram. Relative frequency histogram. So we are going to use this column, class boundary column, and we are also going to use this relative frequency column as well, right? So this is what it looks like. Remember, this was frequency histogram. Now, this one is relative frequency histogram. I mean, besides a little bit of scale adjustment, But only thing that really changed this is right here. Instead of frequency, now we use relative frequency. Remember this first bar between 33.5 to 38.5? It was 2 in frequency, but it was 4% in relative frequency. That's why it goes up to 0.04, 4% right there. The next bar, for example, frequency was 4, but it was going up to 8%. That's why it goes up to 0.88% bar like that. And it follows the same technique and calculation, right? So relative frequency histogram, you use relative frequency here, and you use same class boundary here, right? And frequency histogram, of course, you use just frequency here and class boundary here, right? Okay. Now, what we are trying to do, we are trying to organize actual data into a table, right? The table called the frequency table. And from this table, we're trying to build a graph called histogram. It either looks like this or looks like this, right? Depends on whether you are aiming for the frequency histogram or the relative frequency histogram. Now, what if this topic that we are trying to organize, what type of data? Qualitative data, right? Qualitative data. Remember, there are two different types of data. Quantitative, which is number type. Qualitative, which is non-number type, right? If you open up a bag of M&Ms and you check out all the colors of those chocolate candy, and these are all different colors. Now, some of you see a lot of brown, I guess, but sometimes you see this yellow, and see if there's something else. Oh, they even have a blue right there, right? So there are many different colors. Now, this is non-number form. So how do we construct frequency distribution table with this type of non-number type of data? Well, first you identify how many different colors that there are, right? And you realize there's a brown color, yellow, red, orange, blue, and green color, right? Now this order is kind of random, right? You don't really have any particular order, right? You just have random color that you noticed, and you start to tally them. Tally means counting, right? So you go one by one. The first one was brown, right? So you cross it out and you make one bar like that, right? The next one was another brown, so you make another bar like that. Next one was yellow, so you make one bar like that. Next one was red, red, red. We have 3 red. Okay, so I have 1, 2, 3 red. And brown, one more brown. It's a good idea to cross out, right? Because you don't make mistake. That way you don't make mistake. The next one is orange. And blue, right? Blue. Green. Blue. Right. Okay. Brown. right here, yellow. Oh, another yellow, yeah. And another brown, okay. So going back here, see, I usually do this. I have 1, 2, 3, 4 bar. When I have one more, I cross it out, make a bundle of 5. I mean, you can do it this way, but I prefer this way. Now, I'm not going to go on, right? You get the idea. You have a 2 more red, and you go 1 more red and 1 more red like that. And then you complete the telling. Then you have this tally, which is counting. And you can see that there's a 12 brown, I guess most popular. Next one is yellow. Next one is red and orange. And blue, you only have 3. You only have 3 blue. Wonder why, right? You know, when I was in Australia, they didn't really have blue M&M, right? I guess some type of food coloring regulations. You know, they didn't really have blue M&Ms. Anyway, so how many total do they have, right? How many total do they have? Well, you have to add all this, right? If you add this 22, 31, 37, 40, 45. So you have 45 in total, right? Now, once you get this, figure out the colors and the tallies and frequency, then you're going to build one more column for relative frequency. So how do you find the relative frequency? Well, frequency divided by sum of all frequency. So once you, this is the same table, right? We added one more column. We got the color, the tally, the frequency. Then remember the total was 45 there. So, you know, this is going to be 12 divided by 45. There you got this. Remember I mentioned about the rounding of error, right? This is the case that when you have something like that, put it in the type calculator, it's just actually 2.2666 all the way. You gotta cut it somewhere, right? Cut it somewhere, change that to 7, right? You change that to 7 just like that. They decide to keep 4 decimal point. Same thing in here. I am sure this just goes on forever to all the way. They cut it somewhere, keep the 4 decimal point. Well, fortunately, this one didn't, right? And so forth. So this is how you build the relative frequency. So this is the complete frequency table. Now, of course, using this, you can try to build some type of bar type of graph, right? Now, why don't we actually try to construct histogram from this? Well, remember, we go back to histogram. Histogram, there's no gap between each bar. They are all connected. Why do they are all connected? Because they are in sequential order, right? These numbers, right? It's from small to large. But if you are talking about that M&M color, oops, let me pause for a while. Okay. All right, so, you know, all this, after we construct all this relative frequency column as well, we are now going to build, but as I said, you know, these colors, they are not really in order or anything. They're not really connected to each other. So we cannot build histogram type. You know, in fact, any qualitative data you cannot build a histogram. You can only build a bar shape, bar graph, right? Bar graph. So bar graph, I mean, if I show you the bar graph for this M&M color, it's going to be even easier. I mean, you can read about all this, but remember that M&M color? This is the table. Now you are going to build a frequency bar graph. Now guess what's going to be in there? Different color with frequency, of course. So different color is going to be here, right? Brown, the yellow, the red, orange, blue, and green. And this is going to be the frequency. And then the bar goes up to, for example, the brown goes up to 12, right? And let's say 12 is here. And yellow goes up to 10, goes up to here. But notice that these bars are not, let's say the red goes up to 9, they're not connected. It's a separate bar, right? So if I give you a better looking bar graph, it looks like this, right? Remember, brown goes up to 12, yellow goes up to 10, red goes up to 9, orange goes up to 6, blue, there's only 3 blue, there's a 3 blue, just like that, right? And green was 5, right? Just like that, right? So this is relative frequency, relative bar graph, right? No, sorry. It's a frequency bar graph, right? I had this in mind, right? So frequency bar graph looks like this. Frequency with all these bars, right? Now, the next one is relative frequency bar graph. And it's not that difficult to guess which 2 columns that we are going to use. We're going to use this color columns and this relative frequency column, right? So remember, the brown color goes up to 0.2667. So brown color goes up to here. That refers to 0.2667, right? The yellow was what? The yellow was 0.2222. So this yellow goes up to this line right here, 0.2222. And the next one was red, was the exact 20%, 0.20, right there. And the orange and the blue and the green, just like that. All right. Okay. Now that we talked about the histogram and the bar graph, there's another type of graphical representation of the data, and it's called frequency polygon. Now, before I explain all this, let me show you what it looks like. Frequency polygon looks like this. Looks like this, right? Now, why would they call this polygon? Because if you see this shape with this x-axis, it's actually closed shape, right? If I just rebuild it like that, right? It's actually closed shape. And of course, all this is supposed to be a straight line, right? All this is supposed to be a straight line. So it forms some type of polygon. That's why they call this frequency polygon. So how do they actually build this frequency polygon? Well, check this out. Let's say you have this frequency distribution for the calculus final test score, and you have this table. Remember, these two are the class boundary. So this is class boundary. You have the lower boundary and upper boundary. You have midpoint, which was x before, and you have the frequency, and you have a cumulative frequency. Now, remember, how do they get this cumulative frequency? Well, Well, first of all, cumulative frequency, the first one is just the same. But to 5, you add 10 from here to get this. To 15, you add 30 added to get 45. To 45, you add 40 to get 85. And to 85, you add 15 to get 100. So you keep adding the previous frequency to get the cumulative frequency. Now, once you get the cumulative frequency, then what? Then what? Well, now, then you have this full table. For this frequency distribution table, from this frequency distribution table, now we are trying to build what's called frequency polygon. Now, what column do we use it? Well, look at this right here. This is going to be all this class boundary number. Now, first one start with this one, right? And then, no. Sorry. You actually use all this midpoint, right? All this midpoint. So you use the midpoint here, midpoint here, midpoint here, midpoint here, midpoint there. Now, you have all this midpoint, but where do they get these numbers? Right? Where do they get these numbers? Now, this, the very first number and the very last number that we got this number just by looking at this pattern, right? You see the difference is all 10. I mean 1. No, did I say? The difference is all 10. So you figure out that the same pattern, then this is just going to be 10 down from here, which is 44.5. Now this one right here, from 94.5, this is 10 up, which is 104.5. Because if you look at the midpoint, the actual point that we have is from here to here. That's the actual midpoint, right? You don't really have any one of these, the first number or the last number. Now, which one do you match though? This midpoint matched with what? This midpoint matched with the frequency. Why? Because remember, we're trying to build a frequency polygon, meaning you match the midpoint with the frequency. We use these two. So 54.5, which is the first midpoint, frequency was 5, so you get this point right there. Second midpoint was 64.5, frequency 10. 64.5, frequency 10, you get this point. Third one, 74, 30. 74.5 goes up to 30. Next one, 84.5 goes up to 40. And 94.5 goes up to 15. So far you have 1, 2, 3, 4, 5 different points matching the midpoint and the frequency. Then what? Then remember, then you ground it. You get another, got the same pattern. You get another, the very first point and very last point. You notice that the difference is just by 10. So you go 10 down, you go 10 up, you get this 2, and you connect all this point with the straight line, and you have this frequency polygon. And this is how they explain how to build this frequency polygon, right? Time series graph. time series graph is another graphical representation of data. Now, this is not one of the main topic here, so I'm just going to briefly introduce this. Time series graph, you've seen it all the time. It looks like something like this, right? You've seen it in magazines and newspaper. This is about US CO2 emission amount, right? You've seen like, you know, this type of graph, you know, that describes stock market, the interest rate, you know, the mortgage rate, you know, all these things. It progress as time progress. This is what we call time series graph, and it looks like this. I mean, this is different years right there. This is different amount, and they got these point. Once you get this point, you again connect with the straight line to get the time series graph, just to see the general trend, right? Okay, so that's it for this chapter.